Delta, Priya.
Morning, students. So today we are going to learn about thin linear antenna unit number 2. Generally, you know that importance of electrical charges. So these electrical charges responsible to provide or to generate electromagnetical fields. All these electrical charges are time varying functions. These electrical charges are able to propagate in terms of electromagnetical waves, from where these electromagnetical waves further responsible to provide radiation. So in previous lectures, we are familiar about importance of radiation mechanism. So those radiation mechanism categorized into single wire, two wire, and a dipole. So in past video lectures, we found time varying function parameters for half wave dipole. So in this lecture, we concentrating on retarded fields. So what are the retarded potentials involved in half wave dipole? So this radiation in free space or open-ended medium can be perfectly achieved by the help of some radial body, especially called radiators or antennas. So this antenna is able to radiate or receive some electromagnetical waves. So these antennas may be helpful in terms of either by transmission or by receiving some electromagnetical energy. So this electromagnetical energy between transmitter and receiver is said to be perfectly synchronization. Then you are able to achieve some matching network between transmitter and receiver. To achieve that goal, you have to design so this antenna system with more important requirements such as some radiation patterns, total power radiation, or input impedance efficiency. Like these parameters are able to justify or able to distinguish the importance of good antenna system designing capability. So these features are achieved in this half-wave dipole by means of solving some Maxwell equations and by using some boundary equations, etc. So these antenna configurations are perfectly achieved with the help of certain types of the radiators, so that importance of radiation mechanism can be able to solve this antenna fundamental property. So this type of antenna fundamental properties are perfectly synchronized or perfectly synchronized by providing some Maxwell equations on this type of clarification. So for a given time varying fields, suppose if you wanted to know the time varying equations for that fields, so let that fields should be some v of r slash t. So v of so thus the time varying fields for the particular potentials are So V of R comma T. So this V of R comma T is the potential generated by that vector along the particular time varying parameter. So this V of R comma T, we have the function formula. So 1 by 4 pi epsilon integration rho V of R comma T by R dV. So what is this? This is the volume integration, volume integral. So our volume integral covered overall charge density function rho V across coordinates R comma T. So this charge density function can be accumulated through a specimen of the radiation, or simply call it as some resistance body R. So that's why in denominator we have R the term. This R the term is perfectly synchronized with your volume integration dV. So that's why the function V of R comma T equal to 1 by 4 pi epsilon integration rho V of R comma T by R into dV. So this is the time varying field potential form to the various V of R comma T. Now you wanted to express this function in the radial vector. So that is the voltage or vector such that A bar of R comma T. So the A bar of R comma T equal to U by 4 pi integration V current density J. So J of R comma T by capital R into D. So this is the Maxwell approach which is available in cross. So this Maxwell equations are further read to provide the resistance terms. So let we watch how this resistance terms are be used for your radial bodies. So by using this Maxwell equations, let we plot, let we demonstrate somewhat of the equation from the previous vector Maxwell equations. So this is the fundamental equation from your previous. So by expanding the cross products, you are having some minus mu j plus mu epsilon del dou v by dou t plus mu epsilon dou square a bar by dou t square. So by using this one, del square v plus del dou a bar by dou t, that equal to minus rho v by epsilon. So that more rho v by epsilon can be rho v by epsilon is so this is rho v by epsilon. So del square v. So del square v plus del dot dou a bar by dou t. So that equal to your minus rho v by e. So we will watch the full derivation in regular classwork. So del square v by plus del of dou a bar by dou t equal to some minus dou v by epsilon. So del square a bar minus you can substitute from this one. So minus mu j. So del square a when you can substitute this one. So this one. So mu e dou square a by dou t square equal to your minus mu into j. So by simplifying this expression, del square a bar can be equal to del square v minus mu e dou square v by dou t square equal to minus rho v by e. So del square v minus mu e dou square v by dou t square equal to minus rho v by epsilon. This is very important empirical relation to solve the retarded potentials in our antenna wave propagation. So from this example, we establishing two retarded potential, which is in A form and B form. So A of R comma T. So this is one retarded vector potential form, and this is another retarded vector form. Very important for our signals. So this is your A of R comma T. So A of R comma T is your mu by 4 pi. So A of R comma T equal to mu by 4 pi integration J of R bar comma T minus R by B divided by R dV. So V of R comma V of R comma T equal to 1 by 4 pi epsilon integration G to B rho B T of T by R. So A of R comma T equal to mu by 4 pi integration J of J of R bar comma T minus R by V by R dV bar. So similarly, V of R comma T, V of R comma T equals to 1 by 4 pi epsilon. So 1 by 4 pi epsilon 1 by 4 pi epsilon 1 by 4 pi epsilon integration rho V of R bar comma T minus R by V divided by R. So these two equations are popularly known as retarded potential expressions for thin linear antennas. So that we established some radiation from alternating current element. So if calculated outside, so this current expressions that J equal to 0, so the field can be expressed in terms of this vector potential capital A. So to calculate the electromagnetical field, so to calculate the electromagnetical field radiated in the space by short dipole. So the retarded potential expressions are more popularly used. So why these retarded potentials are more popularly used is nothing but they are used to establish, they are used to calculate the electromagnetical fields. So to calculate the electromagnetical fields radiated in the space by this short dipoles, this type of retarded potentials are popularly used. So these short dipoles has some alternating current elements. It is also called as oscillating current element. Why? Because the current produced by uh, movement of charges, all charges are in oscillating condition. Similarly, an electrical current, so an alternating current element is considered as basic source of radiation. So this alternating current element is considered as a basic source of radiation. It can be used as some building block for any antenna analysis. So when you are talking this electrical fields, when you are talking this electrical fields, so the current element. So the concept of this retarded vector potentials. So this is which is discussed in previous very most useful. So let we move forward. Let me move forward. So in general, so let me move forward. In general, a current element ideal, a current element ideal.
Hello.
So in general, when we are talking about this electromagnetical fields, in general, the current elements which are being represented here, ideal is nothing but the element of length dl by carrying the current capital phi. So this length of thin wire is assumed to be very short. Why? Because we are talking about thin wire. As we are talking about thin wire, how to establish the radial retarded vector potential. This length of thin wire is assumed to be very short. So that filamentary current can be considered as constant along the length of an element. That is useful. That is useful for your purpose. That is useful for your purpose, such that majority of devices are nowadays which are be able to calculate the retarded potentials. So that important of this approximation is based upon the case for current carrying antennas. So with this idea, so let us study how to calculate the electromagnetical fields due to alternating current element. So already uh, we have some basic knowledge about thin wire, two wire, like a dipole. Now we adopt this retarded potential knowledge on this alternating current element. So for that alternating current element, consider very popular spherical coordinating system. So consider this spherical coordinate system and consider that alternating current element ideal cos omega TV is located at the center of the particular particular sphere. So that so the aim to calculate the electromagnetical fields. So this the aim to calculate the electromagnetical fields which are located at a point P from that origin. So this current element's ideal cos omega t placed along the particular z-axis. So this z-axis elements are very important for our valuation purpose. How to locate the point from a fixed target far distance. So while we are discussing with the antenna applications, this important mechanism to locate the target detection, this type of field estimations are popularly used in practical. So that's why let us write the expression for this case, vector potential at a point, some stationary point P, by using this knowledge. So that potential is given by some, let's take A bar. If that particular A bar is the particular potential, we take the A bar. So A bar of R, A bar of R equal to mu by 4 pi integration V J of T minus R by V divided by R dV bar. So this is very popular formula. This is very popular formula anywhere in our discussions. This is very important popular formula. Okay. So you have to notice the point, that is A bar of R equals to mu by 4 pi integration J of T minus R by B, J of T minus R by B divided by R into T. So one more equation along this one. So that is your is it so that is AZ. So AZ equals to mu by 4 pi. AZ equals to mu by 4 pi integration V J of T minus R by V divided by R along with the volume integration dV. So these equations are very popularly used to estimate the importance of the vector potential at a point P using this knowledge. So this vector potential sometimes will able to help you to calculate the undesired targets which are be available on this particular case. So this is the point. This is the point where uh, so some electromagnetical field at a particular point P when alternating current element ideal cos omega ct placed at the origin. So this is the Cartesian coordinate system. So this is the Cartesian coordinate system, x comma y comma z. So for this x comma y comma z, so you are be able to place the well. So ideal cos omega t, ideal cos omega t. So this ideal cos omega t placed at that origin, set for point P. Set for point P, the importance of these fields are ER comma H theta comma E phi, HR comma H theta comma H phi, as we know that in our past readings. So from that knowledge, you are able to uh, write out some the net equation. So this is the net equation: integration v j of v minus r by v dv bar, and that equal to your ideal cos omega of t minus r by v. So that Hedgen dipole, that Hedgen dipole is randomly used for your importance of the value. So that Hedgen dipole, that your integration 0 to v j of t minus r by v, integration j of t minus r by v dv bar equal to some ideal cos omega t. That ideal cos omega of t minus by v. So the Hessian dipole or radiation between a current element and electrical dipole are very important empirical relations that to solve this Hessian dipole. So this Hessian dipole is nothing but an infinitesimal current element. So Hessian dipole is nothing but it has an infinitesimal current idea. So actually, such current element does not exist in the practical real life, but it serves as a block in electrical fields of alternating current element. So that alternating current element contains in the terms of building calculating the field of practical antenna using the particular integration. So it is that field of an electrical dipole which is corresponding to observe the net field lengths. So this GN dipole is nothing but it can able to calculate the current element ideal. So that actually such that the current element does not exist in the real life. So, but it serves as a block in electrical field that the alternating current elements contains in terms of the calculating the field of practical antenna using the integration in the so electrical parameters are to be solved for our greater extent. So Hessian dipole consisting two equal and opposite charges at the end of current element. So those current elements are separated by minute short distance. So that minute short distance equal to that dl which are we indicated in that figure. If this current is able to if the wire between two spheres were that charge can accumulate very thin as compared to the radius of the sphere. Thus, if the current I is uniform through the wire, so the distance dl is greater compared to the radius of these spheres. So this wire between two spheres where charges can accumulate very thin compared to the radius of the sphere. Thus, for the current through the wires, also the distance dl is greater as compared to the particular radius of the spheres. So this current current I equal to Im cos omega mt, where Im equal to maximum current, but maximum current traveled through the antenna space, so that I equal to Im cos omega t. This is also very important. This is also very important equation. So then the charge accumulated at the end of the element and current flowing through this wire related by each the expression that you have to accommodate. You have to accommodate the value that equal to your dq. So dq equal to Im cos omega t. So substituting these values in prayer, you are able to get the value. You are able to get the value. So substituting the value of q. So in terms of this current, you are able to get V theta equal to ideal sin theta sin omega t by 4 pi epsilon omega r power 3. So substituting the values may be able to get the radial pattern. So that is equal to substituting the value of q in terms of this current, that the current will get the great extent E theta equal to L sin theta sin omega t by 4 pi omega r power 3. Similarly, this is the symbolism. This is the symbolism for so Hertzian dipole. So that Hertzian dipole radiation between this current element and electrical dipole. So this Hertzian dipole is nothing but it is some infinitesimal current element. Actually, such as a current element does not exist in the real life. So this Hertzian dipole is nothing but it is an infinitesimal current element, and that is actually such the current element does not exist in the. So this is the current alternating current element in terms of the calculating the fields of some practical antenna using this integration. So actually, the such current element does not in the real life, but it serves as a block in electrical field of alternating current in the terms building calculated the fields of practical antenna using the uh, integration. So this is the Hertzian dipole. This is a very popular Hertzian dipole. So this is the popular Hertzian dipole. It's a very popular Hertzian dipole. So which is having the element of DL. So this is having the DL. And these are the current that are able to catch the current. So with this Hertzian dipole, we are able to guess the particular so this is also one of the important current distributions in the half wave dipole. And this half wave dipole indicates the mechanism. So this half wave dipole indicates This after dipole indicates the mechanism that current, so that current I equals to like this one. So I bar, so that I equals to that I equal to like this one. So plus and minus, this is the plus and this is the minus. This indicates the charge distribution. This is the charge distribution. So like this is the charge distribution current. So this charge distribution currents are generated from positive to negative. So this is the positive to negative. So plus and minus. So these current distributions are very popular in regular charge distribution. These charge distributions are perhaps more useful. These charge distributions are popularly known as for regular charge distributions. So plus and minus, those are very concurrently used in for our charge distribution. So this charge distributions may be further used to provide the mm, clear-cut idea on this, which are already shown, so that when when such Hessian dipoles are connected end to end, forming a practical antenna, it is observed that positive charge at the end of one dipole gets cancelled by equal and opposite charge at lower end of the next dipole. Hence, when the current is uniform along the antenna, so then there are no charge accumulation at the end of the particular type, so which will radiate the 1 by r power 3 terms. It will be and it should be present. So that when such Hessian dipoles are connected end to end, forming a practical antenna. So it is observed that the positive charge at the end of this dipole gets cancelled by equal and opposite charges at the lower end of the next dipole. So hence, when the current is uniform along the antenna, so then there is no charge accumulation at the end of the dipole. So which indicates the term 1 by r power 3 is absent, and so only in the induction and radiation fields are present. In our previous derivations, we found so 1 by r power 3 term is absent, and only induction and radiation fields are present. So that the chain of this Hessian dipole forming part of antenna, that should be shown in that figure. So, but if the current through the antenna is not uniform throughout the accumulation of these charges on this feed point of electrical component normal to the surface of this particular pipe. So by this one, so the radiated power, so the radiated power. So PR equals to beta naught by 2 omega ideal sin theta by 4 pi CR power square. That is the power radiated. So power radiated by the thin linear antenna. So consider a current element placed at the center of the spherical coordinating system. Then the power radiated. So then the power radiated for uniform. Consider a current. Consider a current element placed at the center of the spherical coordinate system. Then power radiated per unit area at a point P that is calculated using this point vector. So that the radial power. So that the radial power here. So that the radial power here indicated by this is the radial power. So radial power indicated by eta naught by 2 omega ideal sin theta by 4 pi CR square. So the current element that we have. The current element that we have considered previously is not in practical, but it is also hypothetical value. So it is useful in the theoretical calculations such as components of the fields, radiation of the power, etc. So the practical example of the center fed antenna is an that elementary dipole. So the length of such a center fed antenna is very short in value, and the current amplitude on which antenna is maximum at the center, and it is decreases uniformly to zero at the end. So the current distributions of short dipole as shown in this figure. So if we consider the same current, if we consider the same current flowing through this antenna current element, so practical short dipole both of the same length, then the practical short dipole radiation will be 1/4 of the power that radiated by this current element. So this is because field strengths at every point on the short dipole reduces to half of the values of for the current element, and hence the power density reduces to 1/4. So obviously for the same current, so the radiation resistance for the short dipole is only of 1/4 times. Hence the radiation resistance given by it. Another practical example of an antenna is a monopole or short vertical antenna mounted on this reflecting plane. So let the monopole of length is known h. So again, we consider the same current flow through the monopole of length h and a short dipole of length. So this field strength produced by both the antenna is same above the reflecting plane. So, but the monopole radiate only through the hemispherical surface above the plane. So the radiated power of monopole is half of that radiated by the short dipole. Hence the radiation resistance of monopole is half of the radiation resistance of the short dipole. So that radiation resistance, that RRAD for short dipole is 200 L by lambda square. So general for monopole, double the time of this value. So 400 into h by lambda square. So this half wave dipole is properly distributed the current by means of the value. This RRAD. So that is this RRAD is your current distribution. This is the current distribution of short dipole, and this is the current distribution importance of antenna in reflecting plane. So in this half wave dipole, current distributions are being triangular case here. So why? Because at the end, according to length of the half wave dipole, if length is 0.25 lambda, if length is 0.5 lambda, if length is 0.75 lambda, if length is 1 lambda, 1.25 lambda, 1.5 lambda, 1.75 lambda, 2 lambda. So according to lengths of a half wave dipole, which is varied, in according to the particular half wavelength. So you have very popular radiation. So that's why we postulated in previous one, so that there may be a current distribution. So that we wanted to so investigate. So this is the length drawn here. So this is the dimension of normal half dipole, small l, and this is the half wave dipole here, and this is the regular current distribution. So it is a triangular current distribution. So with this triangular current distribution, the variety of things are being done throughout the branch. So when this offshore dipole is emerges, when this offshore dipole is manipulates the meaningful value, so there may be establishment of the current, the regular and the regular ideas. So by this knowledge in this E content, we are able to present this values in our current distribution diagram. So this is well-known current distribution diagram. In this current distribution diagram, we are able to familiar the readings as well as your net values. So that should have very popularly in this